Yes, please. Oh, we're filming now? I'm sorry for that. Hello, and welcome to our video about sugar. Sugar is just a generalized name for sweet, soluble carbohydrates, many of which is found in foods today. It is composed of carbon, hydrogens, and oxygen. There are 5 different types of sugar. Galactose, lactose, sucrose, glucose, and fructose. Sugar is found in many plants today, but only the sugarcane and sugar beets have high enough concentration of sugar for successful sugar extraction. Sugar production and usage boomed in the 18th century when the first sugar plantations were established in the West Indies and the Americas. Prior to this, sugar was a luxury and was taxed really heavily. It was even referred to as white gold. Fun fact! Did you know that according to brain scans, sugar is almost as addicting as cocaine? As of 2011, about 168 million tons of sugar has been produced, with an average of about 53 pounds of sugar being consumed by person each year. Another fun fact is that sugar can also be used as rocket fuel. The high diet of sugar is being questioned today as it is commonly linked to obesity, diabetes, tooth decay, and numerous other health issues.
What are you doing, Ivan? Get out of here. You're stealing my spotlight. Anyways, as Ivan mentioned before, there are 5 types of sugars: galactose, glucose, lactose, fructose, and sucrose. Now, I have an easy acronym to help you guys remember this because I know it's pretty hard to remember. Golf, but with 2 G's and minus the O. So GGLFS. There we go. Easy, right? Oh, did you guys see how cool that was? Oh my god. But you know what else is even more cool? Functional groups. Oh my. So, 5 sugar types I mentioned before. There are actually functional groups for each one of them. So let's get right into it. Right, so for galactose, the functional group is hemiacetyl. So an easy way to remember this is that you think of hemiacetyl and it has hemi in it. So when you hear hemi, you think of hemisphere. But it's not a half sphere, it's a full sphere, as the carbon in the center is surrounded by 4 things, with a single bond to an oxygen, a single bond to an hydroxyl, a single bond to another element, and a single bond to an oxygen compound.
Whee! Oh shoot, are we still filming? Brian!
Well, where we last left off, we were talking about galactose, but let's move on to glucose. So glucose has 2 forms, a straight chain and a ring, and each of those have different functional groups. So for a straight chain, there are 2 functional groups. A hydroxyl, which we've already learned in Miss Hilton's class, so I'm sure you guys remember since, you know, we all pay attention to her class. But in case you don't remember, it's an oxygen combined with a hydrogen, and then there are 5 of those, and also an aldehyde. And an aldehyde is a triangle shape with a carbon in the center, a double bond to an oxygen, a single bond to a hydrogen, and a single bond to another element. And then as for the ring shape of glucose, it's the same with 5 hydroxyls, but then instead of an aldehyde, it's an ether with an oxygen in the center and carbons on either side. So next is lactose. So the functional group for lactose is acetyl. And the way you can remember this is acetyl. Carbon's a player, you know, so it can't handle 1 oxygen. It's got to have 2 oxygens. So there's a carbon in the center and oxygens on either side, 2 oxygens. And then the next sugar type is fructose. And fructose has the functional group of ketone. Ketone has a carbon in the center with a double bond to an oxygen, and then 2 single bonds to 2 other elements. And then the final sugar type is sucrose. And sucrose has the same functional group as lactose, acetyl. So there we go. That's it. We're done. Those are all the functional groups. Wasn't that exciting, guys? Just like, you know, a certain someone's class.
Oh shoot. The cop stopped me.
Excuse me, ma'am. Do you know how fast you're going? I'm afraid I'm gonna have to see your license to ride ticket.
How about we trade and I'll tell you the importance of sugar?
Well, I'm not supposed to do this, but I do like sugar, so why not? Alright, let's step aside and hear the story of yours. See if it's good to avoid you being arrested.
Okay, well, sugar is an important part of food energy. During digestion, carbohydrates break down into single molecule sugars, which gets absorbed into your bloodstream and gets taken to all the cells in your body. Sugar can also improve the taste and texture of some foods. Some sugar, like table sugar, can be used in an oral rehydration solution, which can help prevent dehydration. And last but not least, sugar is used in the production of fabric, cement, and suffragants. Yeah.
Wow. There's a lot I didn't know about sugar. Man, that's really interesting. I guess I'll let you go. Just for today, though. Hey, where did Cindy go? We still need to film the rest of her part. Wait a second. That's not Cindy. Where is she?
What's up, guys?
Oh, there's Cindy.
Well, the first sugar we have is sucrose. And sucrose is just another fancy name for table sugar, which can be obtained from sugar cane or sugar beets. And sucrose is a white crystalline solid disaccharide, and its chemical formula is C12H22O11.
Hey, what is that? What does that say?
This says fructose, and fructose is a sugar found naturally in many fruits and vegetables. It is added to soda and many fruit-flavored drinks. Fructose is metabolized in the liver and relies on fructokinase to initiate metabolism. It is more fat-producing than glucose, and its chemical formula is C6H12O6. The type of sugar we have is glucose, and glucose is the most important monosaccharide. It is the body's most preferred source of energy. It is also used in animal energy production. Glucose is also known as blood sugar. It circulates in your blood and relies on enzymes such as glucokinase and hexokinase to initiate metabolism. Elevated blood levels of glucose initiates the production of insulin, and insulin facilitates the entry of glucose into your cells. Glucose is also used in photosynthesis and start cellular respiration. The chemical formula for glucose is C6H12O6.
Oh my god, Anthony's sleeping on the project. What are you gonna do about this, Cindy?
Anthony, stop being lazy. Here.
Now we have galactose, C6H12O6. When ingested, it lowers the glucose, blood, and insulin levels. However, if galactose builds up, it may cause galactose diabetes. Finally, we have lactose, derived from the sugar galactose. It's a sugar milk, and for all of you lactose intolerant people, you're not able to digest this.
Sugar! Yes, please.